how to solve 1 raised to the power of x positive 4 raised to the power of x is equal to 16 raised to the power of x. You will learn two important concepts from this particular lesson. One is that how to solve a system like this. Number two, how to apply logarithms. So I mentioned that, let me move on. So first what I wish to do is I would like to consider the system. So let me write that down. So this is the question, so you need to start the answer with the word consider. Consider 1 raised to the power of x positive 4 raised to the power of x is equal to 16 raised to the power of x. Then I wish to divide by 16 raised to the power of x both sides. You will have to write this statement. And this is going to give me 16 raised to the power of x divided by 16 raised to the power of x divided by 16 raised to the power of x. Now clearly this and this gets cancelled. This is going to give me 1 over 16 raised to the power of x. How am I able to write this? Because of the fact if I have a raised to the power of m divided by b raised to the power of m, if the exponents are same, I can rewrite this as a over b raised to the power of m. That's why I'm able to get this. So this is followed by 4 divided by 16 raised to the power of x is equal to 1. Now this can be further rewritten as, now 4 can divide 16 4 times, right? So let me write that down. So 1 over 16 raised to the power of x positive 4 divides 16 4 times. So it's going to be 1 over 4 raised to the power of x is equal to 1. Now 16 is nothing but 4 squared. You all agree with that. So I'm going to replace that over here. So this is going to be 1 over 4 squared raised to the power of x positive 1 over 4 raised to the power of x is equal to 1. Now there is a rule in the law of indices. If you have a raised to the power of m, the whole raised to the power of n, then you can interchange the exponents and rewrite this as a raised to the power of n raised to the power of m. So this is always possible. So by this rule, this can be rewritten as 1 over 4 raised to the power of x. So in fact what I wish to do is I would like to interchange these two exponents. So I would like to bring this as 1 over 4 raised to the power of x, and then I would like to block them out with 2 so that this is retained as it is. So this is the way I'm writing, is equal to 1. So next, since I have run out of space, I will have to utilize a new page, but what I will do is I would like to make the following substitution. Let 1 over 4 the whole raised to the power of x be equal to some t. So this is a substitution I will utilize. So if I were to utilize this substitution, this would be rewritten as 1 over 4 raised to the power of x. I place here t. This has got 2 here, place that, followed by 1 over 4 raised to the power of x is going to be my t is equal to 1. So we would be solving this. This is a quadratic in t and we can solve it. Let me flip to the next page. So I have t squared positive t is equal to 1. So I'm bringing the 1 to the left. So this is going to be t squared positive t negative 1 is equal to 0. So utilizing the quadratic, you get t is equal to negative 1 plus or minus root of negative 1 squared negative 4 times 1 times negative 1 divided by 2. And this is going to be negative 1 plus or minus root of negative 1 squared is 1, negative negative positive 4 divided by 2. So you will be having t is equal to negative 1 plus root 5 divided by 2, or t is equal to negative 1 negative root 5 divided by 2. Now this is completely negative, so we don't need this. We would not be requiring this value because of the fact that the nature being negative totally. But this is going to give me a positive value. So I will retain this and obtain the value. Now since my t is substituted as 1 over 4 raised to the power of x, I will place that value here. So if I were to take this as sum 2, right, so therefore 2 can be rewritten as 1 over 4 raised to the power of x is equal to negative 1 plus root 5 divided by 2. Now we need to extract the value of x. So continuing on, we have to extract the value of x. So I would like to take, this is the important step you need to know, log to the base 1 over 4, both sides. Now you might be asking me, can a log have a fractional base? The answer is yes. Logarithmic quantities can have a fractional base, right? So the best way is, if I have a over b to be equal to some y, in fact let me have it in this fashion, a over b raised to the power of m is equal to some y. How are we going to express this in logarithmic fashion? Can you guess? This can be expressed in this following way. So log a over b is equal to, over here this would be m and this would be y. So log y to the base a over b is equal to m. So if you had to rewrite this, this is going to be y is equal to a over b raised to the power of m, right? So that is the important concept I would like to show you all, that logarithmic quantities can indeed have a fractional base. Now why am I insisting on this? Because this is going to come in handy. So taking log to the base 1 over 4, this is going to be log to the base 1 over 4 of 1 over 4 raised to the power of x is equal to log to the base 1 over 4 of negative 1 positive root 5 divided by 2. Now there is a formula, log a raised to the power of b is equal to b times log a. Now utilizing this is going to be x times log of 1 over 4 to the base 1 over 4 is equal to log of negative 1 positive root 5 over 2 to the base 1 over 4. Now we have another formula, log a to the base a is equal to 1. By utilizing this is going to give me x is equal to log of negative 1 positive root 5 divided by 2 to the base 1 over 4.